Hello, everybody, and welcome to our webinar. We'll start in a second. Just need to get my little laser pointer. There we go. Okay, ready to go. Hello again, and welcome to our webinar here at FLUXANA. My name is Konstantin Renkens, and today's topic is a quite interesting one. We will be talking about laboratory routines and organization. To give you an idea how we here in FLUXANA laboratory or at FLUXANA do it, and I would like to start with a little remark. Feel free to write any questions in the comment section, basically, or there is a question and answer section. Last time we had a little problem because there were some questions that were sent anonymous, and so we couldn't actually answer them because we had no email address to answer to. So if you logged in anonymous, you can also just write the questions to info@fluxana.de or com. That works as well. But also feel free to just write any questions down while you are watching this webinar. And if we have some time at the end, we'll pick a few of those questions. Or if there is no time, we'll just get back to you via email. Okay, today's topic, again, we'll talk about laboratory routines and organization. And to give you an idea about the structure, basically, we want to give you some examples how to answer a specific question. And the question here is, how do I make sure that my analyses are correct? What can I, in terms of organization, develop as routines and habits to make sure that I can always trust my analysis and be confident with what I report on the samples that I analyze. And we will share a bit of how we at FLUXANA do it, with the focus here being that we have the ISO 17025 accreditation. So a lot of that is covered in this norm, basically, and we have to follow the rules set by it. But of course, there are also a few practical tips here that you can apply to any laboratory, regardless of the accreditation status. So let's go into the presentation and have a look. You might have already seen this one in one of this paper in one of the previous presentations. We like to go through it step by step, starting with the sample side of our analysis. And in this case, our topics will be basically the equipment. And a big point here is this metrological traceability. We'll talk a bit about sample preparation. Okay, this overlaps here, the sample and the preparation. We'll then have a look at the monitoring of our measurement equipment. So what comes after the sample preparation. And in the end, we'll also talk a bit about statistics and the monitoring of our actual analytical methods as a total. And this is where then we'll talk about control sheets and all that. And we would like to keep it really practical here to give you some actual advice on how to make sure that you always have the documentation that you need in case any critical person comes along. In our case, it's always the audition that come regularly with the ISO norm we follow. And the main goal of this whole organization and the routines in our laboratory is that we are always ready to answer these critical questions that come from the person auditing us. And it's always basically the question, how can you be sure that the analysis you are doing is correct? So we'll start with some general things and the sample side. And the first thing that we need to get out of our way is, you know, the question of the traceability here. In general, the question is, when it comes to this traceability, what do we as a laboratory have to follow, have to apply as curves of rules? And there are some very simple things. First of all, we always have to be absolutely clear about the identification of samples, devices, and tests. We always have to be sure about our state of equipment and the machines we use. We have to have statuses for equipment that are ready to use or not. We have to have logbooks, and we have to make a documentation on that, and usually also the use of when to use certified materials and when to use a plant sample is also specified. I did copy one of the definitions here. I think you can probably, if you want to read that, I'm not going to read it out loud, but if you want to read it, you can pause the video here basically. And the whole idea is that when it comes to this traceability is that all the steps you take in your library are basically trace it back to a standard unit, an SAU unit, in order to make it comparable to, for example, another laboratory doing the same. So it's basically a chain of tests and routines that make sure that you always do something in a similar way, and you can always trace back to that SE unit or a certificate for a certain piece of equipment. And as I said, the FLUXANA laboratory is accredited after the 70, and that's basically the extract from that. So let's go into a few examples next. So when it comes to this traceability, one of the first steps in laboratory is always using the balance. And so what kind of tests are necessary here? Something, for example, FLUXANA does every day. We do have one of these little testing weights, and we put them on the balance in the morning, and we check the weights and make sure that it's working the same way as yesterday. And one thing to keep in mind here is that depending on your type of balance, you will have to do manual recalibration. Most of the more modern ones have an internal recalibration, and you'll hear that the balance will inform you, hey, I'm doing recalibration, please wait a second, and he will do it automatically from time to time. But with older models, you actually have to have one of these calibrated sets of weights actually, and then tell the machine, hey, I'm putting on the 50, I'm putting on the 10 grams and so on, and he will do the calibration. A practical advice here is you should always do these tests with the same weights that you will later on use. For example, here in FLUXANA, we use a 50 gram, which represents our crucible for fusion. And we have a 1 gram, which basically represents the sample. And we do these protocols every day, document them. And then that way we make sure that our balance, which is used for every other step following this one, is up to date and is working properly. Additionally, as an accredited lab, we have to do some more steps. And the first one is that each year, we have to do the maintenance and testing of each balance we use. We have multiple ones, so each one has an annual date where it gets tested. And there is actually a service here in Germany, the DKD, Deutscher Kalibrierdienst, which roughly translates into German calibration service, and they actually come over and visit us, and they bring all the equipment and necessary stuff to make the balance, to make the the maintenance, and also give us a proof of like this certificate of that step for each balance afterwards, which includes the delta of, and it's a technical document that basically sets the balance is working within these margins of error. And based on that, we could actually, check our test calibration weight. If we don't have one of the expenses one that is calibrated, we could actually, after this first step, we could do an actual determination of the real weight. It says 50 gram, but it might be just 49.9 something. And doing the first step with the external control allows us to find the actual calibration weight for a daily control that we can do ourselves then and document. And yeah, daily inspection and documentation, you will see this coming up a lot. Basically, each morning before we start working, we check with our weights. We note down for each balance what weight was measured and displayed, and we have a protocol so we can be sure that they are all working from each working day to the next. Next piece of equipment, muffle furnaces. The modern ones, they have these nice electronical displays where it basically says the temperature that the muffle furnace is on. Problem now is, how can we be sure that this is true? Again, being the critical person, how can we be sure that if this says 950 degrees, that it's actually 950 degrees? And the way FLUXANA handles this is with testing ourselves. We have one of these, or actually we have two of those thermometers, which have been calibrated externally. These ones we basically send away and they come back with again, a proof of certificates and so on. So you can do either way. You can have them checked inside or outside. And we test our ovens. They're basically powered for the entire working week. We test them on a weekly basis to make sure that they are still okay, or when we change the temperature. So let's say this one is set to 950, and I need something to be at 815 to make an ash, basically. So I change the temperature, I let the oven stabilize, and then I do my test afterwards before I introduce the sample. So one or the other. We do a weekly test if we keep the temperature, and then we do a test when we change it. There is also another way to determine the temperature using these expansion rings, although I think they are basically dying out because I wanted to find a photo for the presentation and I couldn't find one really quick. So the idea is that you put something like a ring in there and you measure the amount of expansion, you measure the millimeters it expands, and that lets you tell the temperature. But I think these thermometers are more present nowadays, and so they're the way to go. Again, for the accreditation laboratory, you have to do, since this is your testing device, you have to do the same certificate, or you have to get the same certificate. As I mentioned, this one we send away. That's why we have two. We always have one in the laboratory that we use, and then the other one we can send out for the annual check, and we get it back with the new certification. And again, also documentation of the test needs to apply here. And also at some point you will see later one, I think, no, it's actually in one of the later pages. But what this means, for example, is that your actual temperature, the one you want to use for your application, might vary from what is displayed, because this is the real temperature. And so if this says 940 or 945, and this one says it's 950, then we'll just set it up that way. And so each oven has a different target temperature, basically. But we have it protocoled, and we can prove that it actually has the temperature that you would use. The materials used for testing and also for the analyzers in general, there are some rules that we need to follow here. We have to have good quality. They should always come from the same source, if that is possible. Or if you change the source for what reason, you need to kind of repeat some of the tests that you need in order again to make it traceable. So let's say you change the flux because you found a cheaper offer or something like that, and you want to make sure that both of your control samples later will perform. We'll talk a bit more details about that in a minute. And yeah, basically, if you change something, you want to check if that works. Again, some additional rules that that apply for accredited laboratories. We have to have the full documentation for all materials used. That includes lot number here. So let's say you're always using the same chemical material, you have to have a specific certificate for each lot number when you change batches. For liquid standards or liquid samples, you have to have an opening date because they have like a special rule that they are good for 1 year after opening. So they basically have an expiring date from the moment you open the bottle. So it makes sense to put the opening date on there. And yeah, that basically ties into this. If there is an expiry date on your chemicals, you have to make sure to check. And if it's going bad, you have to replace it. Yeah, that was the whole part about the meteorological traceability. We'll go into some more sample preparation side now. So we've made sure that we have it all traceable back basically to the base units by the first steps. And now we're coming to sample preparation. As an example here, we picked Fusion, being FLUXANA selling Fusion machines, and yeah, being quite knowledgeable. You know, we know what we're talking about here. So we took this as an example, but it also applies to other machines, presses, mills, whatever. So as a day-to-day routine, you definitely want to have a think about cleaning and maintenance. You know, in order to, in the end, what we want to do is a control sample. And in order to make that happen, we have to make sure that the machine is working and it is working in a good condition. So cleaning, for example, with the Fusion machine, the platinum ware, but also the equipment is important. And of course, doing maintenance every now and then to make sure that let's say this is the interior of one of these gas machines, and you know, just talking about the tubings and so on, to make sure that the machine with age doesn't deteriorate. You have to do some manual maintenances. And then on a more day-to-day basis, what you want to do is the function and parameter check. So function check basically means to you know, observe a preparation once a day, once a week, something like that, in order to make sure that the programming or the parameters are met. And parameter check is just to make sure that the settings of the machine are the same as before. For us as an accredited lab, again, we have to do this on a regular basis. And again, we have to do the documentation. We are not allowed to use equipment that has not been maintained properly. It comes down to the clearance. Basically, at each point in time, our machines or the equipment we use has a status, and it's either cleared or not. And if it's not cleared, I'm not allowed to use it, basically. And yeah, the times of these or the periods of these checks, they vary from equipment to equipment. Mentioned before, we do it for the balance, we do it daily, basically. For these Fusion machines, we make weekly checks and monthly checks, basically, to make sure that they are all operating. Okay, we already did that. I already talked about that. Yeah, so cleaning and care we do daily. The function control, just to watch a Fusion done, we do that usually once a week, let's say. And the temperature control is actually done with a test sample then, and it's mentioned here that we use SO3 as the indicator. So that is one way to do it, but it's only an example. So in our case, we'll see that later again, we do I think it's once a month we do a check of samples, and then a set of samples, and we check the SO3 value to make sure that we don't have differences in the temperature between the fusion equipments. And another check would be, for example, a high silica sample would make us check the homogenization, the agitation of our sample. And again, as an accredited laboratory, we have the clearance issue, and we have the regular checks, and so on. And so that kind of concludes the whole left side, sample and also preparation. So we've got both those covered. And how does this now translate to the actual measurement and the monitoring? I think this is where it gets a bit more interesting. First of all, coming to the spectrometer with the prepared samples, what are the points to check here is, first of all, make sure that the equipment itself, again, is clear and in a good shape. You would be surprised how often I've seen at laboratories outside when I was doing service work, just a dusty sample cup or a cassette, basically. So, which is clear, you know, if you're working, for example, with pressed pellets and you measure a lot of samples over the day, they all come into the same cassette or the same cup that goes then inside your spectrometer, for example. And of course, there will be some dust, and over the time, this will accumulate, and it will always be in there. So it will always be part of the measurement. So you want to make sure that, you know, you clean it when it happens, actually. If you take a sample back from the tray and you see a bit of dust, just, you know, just wipe it away or use a little vacuum cleaner. The function control, a daily test again, is what you can do with the control sample. And there are a lot of convenience points here to make that kind of automatic. We'll get to that in a bit. We have to do drift correction because of the aging of the machine. And we have to also make sure that we check our control, our measurement programs. Again, we'll exclude that right now because that will be the last part about the statistical use of the analytics. So right now, this chapter will basically more focus on the equipment. And another thing is that here in Germany there is this rule: we are actually only allowed by I think it's the federal government law. We are only allowed to operate this machine if we have an expert here on site, and that expert needs to be reviewed every 5 years. So before we can actually turn this on, we have somebody of the operators used as a responsible person, and he has to redo his expertise every now and then. Otherwise, we are not allowed to operate these machines. Of course, these regulations vary from country to country. Additional stuff for our accredited laboratories. Again, we have maintenance and documentations. We have to actually clear our methods when we do changes, and we have to do these regular checks. So let's go back to the one of the step here, you know, to make it a bit practical about the function control. And the use, you know, this is all based now on the use of statistical evaluation. So the thing is, we want to make a measurement today and predict the future, basically. And that's why we use statistics. So a control sample here is a very good way to approach this in a practical way. We choose a control sample that we measure regularly, and we check it against the precision data that we obtained in the past. And if we make a good selection here, if we select a method, actually I have to point here, sorry, I was looking at the other screen. If we select a representative method, this can actually also check the control box for our spectrometer, because we're basically taking one sample, measuring it regularly, and checking if everything inside our spectrometer is still working as yesterday, last week, and so on. And now when we talk about these control samples, they can also cover our preparation. So if you do, you have to collect some data here to actually measure that, because we have to have the precision data to start with. But if we have that and established, we can use these routines to actually make sure from day to day that we can deliver a good analysis, a correct analysis. And the way we do it in FLUXANA is with these what is often called grade checks. So every day we measure a certain sample, and it's actually done automatically. And this one is then checked against a certain plus minus. And the machine tells us at first glance in the morning if the equipment is okay. You see, this is represented then by these green numbers, or here in this case on the other machine, we have the limits next to it. And if our sample doesn't match the limits, it will turn red. So we have a visual indication of how ready is our equipment. And we do the test by measuring a sample every day, basically. And later on, we'll talk about when to replace these samples. I think I'm going to kind of skip over the recalibration simply because there is a full webinar available on video about this topic. Basically, this is the compensation of the aging of our spectrometer. And I actually just copied it over from the other presentation. So we have to have some samples to document the aging of our spectrometer and to compensate for it. And this has different names: recalibration, drift monitors, or setting up samples. The samples are usually pure silicate. The requirements, sorry, was blocking the word, the requirements are here. And if you're more interested into this, check out the other webinar. As I said, it's on video. Basically, question here is, what model do they follow? Do we do the regular model? Do we do the based on control sample? Or do we do both? And but all of these are correct in a way. It's basically a matter of what you prefer. And let's see how FLUXANA does it, for example. The whole equipment monitoring is kind of automatized. So what we do is we check our the auto sampler and the cups. We check when we change the sample, and if we see there is need for cleaning, we do that. Or we do it at the end of the week. Every Friday there's cleaning day, and everybody has like little tasks, and cleaning the spectrometer is just one of them. We do a daily drift correction for our in-house methods, mainly because we can automate them. That's why we have the pictures here. You can see there is a scheduler here, and here we have oh, that's German. This is basically a timetable on when to do these repeatable analysis, and they include the drift correction and the control sample in one go. So the samples are on the machine, we have it remotely activate, and it will do all that for us, and we can have a look at the data at the end. And there are some other standardless methods and stuff we use not so often. They will be done weekly or monthly, and the control sample will follow. But for our workhorses, let's say, we do it on a daily basis simply because it doesn't affect our working time, and we can easily remotely start it. Of course, the documentation here, again, very important, because this we also do for our precision data later. And after tests or as a service or recalibration, we have to again make a release. We have to make the status of our machine echo again. And yeah, as I said, we have daily, weekly, and monthly facts, which are basically just checked off the list. And we're running out of time, so I need to hurry a bit. Documentation, well, you can do it in paper, this is actually my paper journal, which I'm doing, or a more modern way to be a paperless laboratory would be a laboratory information management system. So you basically do what you do in paper in here, and just writing down what equipment, what chemicals you use is a great way to document it. In our case, we have to actually sign those to put them date and sign to make them conform with our norm. Then they have to have a structure so that we are audible every day. And we are not allowed to do corrections or use pencil, because if we do have a correction, we have to cross it out, write it again and again, do date and abbreviation that we changed it. So no Tipex allowed, for example. So last part, as I said, I took a bit long, so we'll need another few minutes. I'm sorry for the delay at that point, but please stay with me. So the whole monitoring, this is the combination now of our application and the controls we just talked about. So what's the idea behind that? In order to be sure about our analysis, we have to have a certain expertise and experience with it. So in order to make these in order to monitor our methods, we have to meet these prerequisites. We have to have a valid validation about the correctness. We have to establish long-term stability in terms of we have to connect drift monitors, and we have to have a suitable control sample. For accredited, we have to do these validations with the determination of the accuracy and precision, and we have to regularly test them. That means we have multiple methods for that to come later. So what it basically comes down to is when we are doing the validation, we verify the correctness of a certain analytical method at the time of release. And for that, we have to use a CRM because we have to make sure that it's a sample that we know everything about, and CRMs are just the way to go here. And the test basically is we check the mean value of our test samples, and we check them versus our bias of that standard, and then the mean value or our error of confidence, which is a statistical evaluation. The formulas are all present, but I'm not going to go into detail here too much. Once we have that done, what we want to calculate over the long term is the precision. And basically what this means, we remeasure a sample regularly. You said, you remember I talked about the control sample that we do daily. So we measure one sample daily, we collect that data, and based on that, we can make a control chart. We can see how that performs over the long term. And then for each day, we can make this check, and then we can put it in a control chart, and he will tell us, this is within my expected tolerances or not. This is what we do for daily samples. For more rare methods, it's often not necessary to do that every day. We only do it when we use the method. So for our for samples, we only do every few months. We don't do daily checks, but we do the same check when we actually analyze it. So if somebody sends me a sample and it's one of those methods that we don't use daily, I will always control I make a suitable control sample when I make my customer sample, and I check and I make sure that it works. In the accredited laboratory, that also means we have to test annually if we didn't use the method during the year. So let's say we have one method that we have not used for a year, then every January we have to do these tests to make sure that it's still within the accreditation. So basically in routine, what it comes down to is to have a plan about the changes. And just to give you an idea, daily, we should always check the equipment. It doesn't take much time, and it just makes sure that the basis of our analysis is working correctly. So in FLUXANA, every day we do the balance. And sorry, that was too fast. We do the balance. We do the oven, well, every day if we change temperature a lot. If not, we do it at the beginning, at each Monday, basically. And we do these control measurements every day, simply because they don't take time at all. We just automate that with the scheduler and the whole automatic grade checker and whatnot. Weekly controls, well, often again, in terms we haven't checked it. Standardless or rare methods. There is a list basically. They come weekly and monthly. On a monthly basis, we have more tests here now. So we do the fusion equipment. We do new preparations of our control sample at that point, because the preparations at some point have to be replaced. So we do the new specimens monthly and combine it with our fusion equipment check. We check the methods with these results and see if they match in the precision data, basically. Other laboratory equipment, well, let's say mills or something like that. And also software upgrades, software updates. So make sure that even if that the machine you're using, especially if it's connected to a network, do the software updates. And then finally, we have the annual ones, which happen every month. That doesn't necessarily mean you have to do it every January, but you have to keep it in the rhythm. So some of our applications and equipments get checked annually, but then others go, like, for example, the XRF can go in January, the temperature can go in May, and then the balance gets their service in September, depending on how what the annual order is. All right, sorry that it took so long. We did like a 5-minute extra. Hope that will not keep you from joining the next seminar. The next one will be an application again, so we'll talk about some actual recipes and solvents. Thank you very much for your attention. Have a good day, and I'll check the questions and come back to you by email then. Goodbye.